Item 6 says, a right circular cone is shown in the figure. Point A is the vertex of the cone and point B lies on the circumference of the base of the cone. The cone has a height of 24 units and a diameter of 20 units. What is the distance from point A to point B? So point A is the vertex and point B is a point on the circumference at the base of the cone. And all they want is an answer. They're not asking you to show your work. So this is way beyond anything I did in middle school math, but I guess middle school math has changed. So I'm going to need to work this out on a sheet of paper. In a right circular cone, the height of the cone and the radius of the base form a right angle. We know the diameter of the base is 20, and that way we can find out the radius. Half of the diameter is the radius, so the radius is 10. So we know the radius, we know the height, and now this line that we're trying to find that runs from the vertex to a point on the circumference of the base, when we draw that line, then we have a right triangle, although this line isn't exactly straight. Pretend it's a right triangle. So this line that we're trying to find is like the hypotenuse of a right triangle. So now we can use the Pythagorean theorem to find C, to find the length of that line. The Pythagorean theorem is a squared plus b squared equals c squared. So we'll say a is 10, which is the radius, squared, plus b, which is the height, 24 squared. That'll equal c squared. 10 squared we know is 100. I'd have to use my graphing calculator to figure out that 24 squared is 576. 100 plus 576 equals 676. So c squared is going to equal 676. I want to find c, so I would have to go back and use my graphing calculator and find out that the square root of 676 is 26. So the answer is 26 units.